Всем привет.
Hi all.
Поговорим сегодня о безопасности Frontend
Today we're going to talk about the security of front-end applications.
security testing или сокращенно FAST.
Fast approach front-end application security testing.
И оптимальном
The
месте
tasks
для
of a fast analyzer and the best implementation in secure development. My name is Mikhail Parfenov.
Я являюсь application security
I'm the application security
архитектором,
architect.
занимаюсь построением процессов безопасной разработки.
I build secure development
Но прежде чем говорить о
process architecture
вспомним, как у нас
and front-end.
происходит защита.
But before we drill down on this, let's remember how all web applications are
На этапе
protected.
у нас
Let's quickly list this. At the development stage, this is where we write code. We use analyzers such as SAST analyzer
сторонних библиотек,
to
композиционных.
perform the analysis of third-party libraries and composition analysis. At the testing stage, we add a DAST analyzer when an app is already compiled. This is the composition analysis right at the testing stage. Then everything is rolled out to release service.
Свои средства защиты, такие как антивирус.
This is where we have our own protection tools like antiviral software. We have the vulnerability management
Есть
process running in real time. We have EDR systems and container security specialized systems.
свой периметровых средств защиты.
Then we have our perimeter protection tools. These are
Anti-DDoS
NGFW,
и так далее.
IPS, web application firewalls, etc. All events go into the SIEM according to response rules. We identify incidents. Therefore, back-end systems are pretty well protected. However, where are the front-end applications?
Файлик, да, бандл
There is a certain JS file, a bundle
пользователя.
built by a front-end app. Upon a user's request, we provide this file to them. What happens next?
То есть
No one
файлик
knows.
работает где-то на стороне
The
пользователя.
file works somewhere on the user side in the web browser.
Косвенно судить о том, что происходит по
We can only judge indirectly based on what happens on the backend side. For instance, the user has passed authentication. We issue an authorization token. With that, they request some personal data if it's a personal area.
неизвестно. Где-то
What happens to the data next, we don't know. Whether it is somewhere at the user side, whether this data has been stolen, we don't know that. What makes the situation more complex for front-end apps? Because there is a very popular case with front-end where a part of code is uploaded from third-party sources. And this is done by the
мы выносим во внешний
client's browser. Sometimes some scripts operate on external CDNs.
партнеров.
Then we also have third-party services running in the browser, provided by our partners.
В работе с заблуждением
In my
даже
day-to-day work, I often run into this misconception, even popular with experienced developers. They come and say, why would I apply security analysis to front-end? We need to protect the back-end. Everything is connected to the internet. Why would we apply that to the front-end? So I have to explain the following to them. This is a misconception. That is not actually right.
ценность.
What may you possibly need? What would be the value for attackers,
Первое.
which is contained in our front-end apps? Let's take a look at these. First, personal data or other sensitive data, like authentication data, credentials, logins, passwords, some one-time passwords, OTPs.
Могут быть данные банковских карт,
This can be
все что угодно.
banking card data, commercial secrets, trade secrets, etc. Second, user profile. This is somewhat similar to personal data. I believe it's for everyone to see that in a
Например,
number of countries, including Russia, cookie files a certain unique identifier
считается
which
персональными данными.
marks the user's browser is considered to be personal data. How can attackers possibly use these in
Какой-то конкурент.
next?
Он
There are
может использовать
multiple cases. If it is the competitor,
таргетированной рекламы.
they can use this cookie to show competing ads, to serve competing ads.
Таргетированной рекламы.
If it's a different type of attacker, they can use this data for phishing banners
Третье.
to further exploit the attack against this user.
Пользователя.
Third, attackers care about user activity. If it is a case of fraud, That might be the transfer of some bonus points
каких-то транзакций.
between users, payment for certain goods or services, any transactions, or anything of that kind. Third, any web app, website, a portal, a personal area is the face
Интересная репутация наших
of our business.
За счет этой
And
репутации и доверия
attackers are interested in the reputation of our company and our brand.
какой-то мошеннический
By
попросить
denting our reputation,
для получения какого-то
they can use some fraudulent banner, lure them into entering their credit card data, etc. Next,
устройств наших пользователей.
attackers are interested in the computing hardware of our users. Probably you know about JavaScript miners. They're still there, they're not gone anywhere.
Его процесс
A certain script
криптовалюту
starts mining cryptocurrency in the user's browser. This is how attackers monetize their hacks.
в самих
And finally, we regularly learn about vulnerabilities in the browsers themselves. By exploiting these vulnerabilities, attackers can infect the system of our user and create a botnet
любыми.
for subsequent attacks of any kind.
Стоят фронтенд
Let's take a look at the components of a front-end app. There are two key groups. First is the application itself.
веб-фреймворка, на котором
It's composed of a web framework.
собственного
This is
и зависит
the framework is based on its own code,
публикации фронтенд-приложений
direct dependencies, and transition dependencies.
или там парочку бандл файлов.
Normally,
Получается
it is
толстенький JS-файлик, как раз таки
built into one or a couple of JS files. It becomes a pretty large JS file.
это сторонние
This is when the user is trying to open a page. And second, these are third-party JS services. These can be internet analytics, web analytics, internet counters, marketing systems,
может быть карты,
capture services, online chats, online maps, etc.
которые вынесены во внешние
In this category, I put all external libraries
которые находятся вне нашего
living in external CDNs, because these live outside of our controlled area.
размер
Statistically, over the last 10 years, the average size of JavaScript applications increased by more than 10 times.
Там рост
If you take a look at the present-day apps based on modern frameworks, it became 20 to 30 times larger than it used to be 10 years ago.
приложения не коррелирует с их сложностью.
Normally, the size of applications does not correlate with their complexity. In my work, I saw lots of
Но при этом
landing pages which only collect
мегабайт.
the phone number, but the script size might be up to 20 megabytes. Why such a size? This is a question.
В зависимости
The key thing is dependency. Dependency in JavaScript,
NPM зависимости, да?
like NPM dependencies.
Небольшое JavaScript приложение.
This is a pretty small JavaScript application.
Занимался композиционным анализом
I was in charge of component analysis of applications written in various languages, but
то есть в других
it's only in NPM that I saw a depth of 15. I haven't faced any depth of that level in any other language.
приложений
Another specific feature of JavaScript applications is the following.
и обфускации.
Minification and obfuscation are almost
20 мегабайт.
everywhere. If you recall the 20 megabyte size,
Сжать
you see why you use that. This is to just compress it at least down to 15 megabytes. For obfuscation, some cloud services, third-party services, use obfuscation to make the analysis harder for attackers, since the whole code has been transmitted to the browser and somewhat protect their intellectual property. It's a weak protection measure, but still they're trying to protect it. On obfuscation,
коллеги, кто занимаются
by
безопасностью
the way, colleagues in charge of IT security,
такой задачей, ну, у меня
I believe
один раз
you
это было.
run into such a task on a regular basis. I used to do that once in a month at least. Distinguished IT security people, please check this code for security.
Приходилось как-то проверять, но на
And every single time we had to run a certain check.
это на свой страх и риск. Что
But
это делать,
we always act
понять, ну, практически невозможно.
at our own peril, because the risk is somewhat around 80%. We can create a synthetic page, we can open the browser console and see whether there are some queries going to some third-party external
И вторая интересная особенность
unreliable service. Today, they're not there, but tomorrow they may appear.
Практически весь мир использует
For
буквально
obfuscation,
2 или 3 основных библиотеки.
there are 2 to 3 key libraries used for obfuscation internationally. We regularly hear about
Можно себе представить, что произойдет, если когда-то закладку добавят в мини-локатор, который использует почти весь мир. То есть на следующий день мы получим такую мини-катастрофу глобальную.
backdoors. And what if there is a backdoor which
Обеспечиваем безопасность.
is discovered? It's going to be a large-scale disaster. How do we ensure security?
Анализаторы безопасности.
We use
Мы все
information security analyzers.
Давайте
We
пройдемся
know
по каждому из них.
about them perfectly. Let's take a look at each of them in the context of front-end applications.
Отличные инструменты.
Static application security testing. SAST analyzers, these are great tools, pretty well established. They have great reputation. We should use them. But what's the situation with front-end applications?
Самых сейчас динамичных.
JavaScript is one of the extensively developing languages. Therefore, SAST analyzers must
синтаксических конструкций.
keep pace with them at all times, support the respective syntaxes
False positive.
and structures. The first problem is false positives.
Точнее.
The
JavaScript
second problem is much
язык. То есть
more threatening. It is an interpreted language, which is executed as text in the browser.
JavaScript сталкивался, знают про функцию
Those of you who deal with JavaScript, you know about the eval function.
текста.
This allows you to execute code from a string.
JavaScript
Based on this function, encryption is based, so we can
и передав ее в
run a small decryptor function. It goes to eval, and we can
понятно,
actually
что анализатор
execute
зашифрованный код
encrypted code.
сможет.
Of course, no static application security analyzing,
Eval
so no SAST analyzer will be able to analyze
alert.
encrypted code. Therefore, they mark encrypted code with eval as a critical thing. If there is
Природа именно
an eval call in the code, that's a red flag.
И
But there is a certain trick.
уже SAST-анализатор не обнаруживает. То есть
Using such a trick,
вот этим
you
пользуются.
can prevent analyzers from identifying the eval function.
То есть
And attackers are actively discussing this approach. There are respective forums out there.
достоверность
Well, overall, SAST analysis is pretty good, but the reliability, the validity of this analysis for client-side JavaScript leaves much to be desired.
SAST-анализатором обычно не проверяются код каких-то сторонних сервисов.
Code from external services is not checked by SAST analyzers. Normally, the code is obfuscated, so there's nothing to look into.
Про
Composition
JavaScript, да, там
analysis, SCA. If you take at the dependency tree, there are dozens and hundreds of dependencies. How can possibly do without SCA? It's useful, it's all fine.
в тьме этих зависимостей уязвимые библиотеки обновляем.
We'll look into
Но
vulnerable libraries and we update them. But what is the problem associated with SCA?
я знаю, вот у
I'm digressing now. I know that Codex in a number of companies
и для фронтенд-приложений
analyze Docker images. And this is how they implement SCA, which is a bit incorrect for applications. Why so? Because in the Docker image, they put a bundle, a compiled bundle file, which contains all the dependencies in a single file. And no SCA analyzer can actually break this down into separate dependencies. If you have SCA for front-end applications, that must be on the source code level with a packet manager file,
Второе.
like NPM or other files. That's point number one. Point number two.
В
In my routine work,
безопасности
I participate in quality gates for security purposes.
Quality Gate
And for backend developers, quality gate is a challenge because you have to justify that in this case, this is a false positive. In this case, it's not, but it's not very critical. So this is an ongoing process. There is a similar case with dependencies. We always check whether this specific vulnerability is relevant, and we demand that it be fixed by the next patch version.
проходит очень легко.
Normally, for front-end applications, quality gate is passed pretty easily, not because nothing is getting detected, but rather the reason is that
Там дата
what do vulnerabilities look like?
ошибки парсинга и там
Data transmitted in an incorrect format leads to
какой-то
a
страшный
passing error and extensive resource use. Can this be used for attacks? Rather not.
именно в библиотеках для
Critically important vulnerabilities identified in libraries, the criticality is not always high. It is more relevant for the server-side JavaScript and not for client-side. DAST analyzers. DAST analyzers are normally used to identify entry points for the backend. This is to proceed with fuzzing API. Yes, DAST analyzers at the verge between the front and backend identify X, SS, both reflected and stored ones. Speaking of the front-end side proper, it must be only DOM-based XSS, which runs without any backend participation. What am I driving at? If we need to make sure reliably what our applications are doing, it's only one point. This is the content layer of modern browsers. So we move away from the front-end app, we take a look at the content layer of your browser. And this is the only place where we can all actually see what our app is doing. Respectively, front-end applications and their operation, it's a blind spot for security. We cannot see what is going on out there, and we don't understand that. This is why attackers are actively exploiting this area. 2018, a well-known European airline, their ticket booking website was hacked due to a vulnerability, and the attackers decided to monetize the vulnerability this way. They added a small chunk of JavaScript code, which would hijack the bank card details, transmitted it to the attacker's website. It was detected 10 days after. Several dozens of thousands bank card details were stolen. It was a huge fine imposed under GDPR over $2.28 million. The second incident, Russia 2022, an external JavaScript service. Probably many of you have heard about this incident. A service has been compromised, they injected some code. That was part of a political activity. Therefore, it was a political incident. It hurt lots of companies in Russia. I frequently see this misconception that front-end applications must be protected, especially when you have some payment forms, personal data, personal areas. This is not quite true either. Well, actually, any attacker can add a payment form, a data collection form to any website, thus luring users into sharing their data using social engineering techniques or phishing techniques. Of course, this incident caught the attention of Russian and international regulators. PCI DSS introduced requirements, which become effective in March 2025. They added two requirements. Requirement number one: perform stock-taking with the necessity to use all scripts based on payment pages. And second, control all changes to the payment pages. It does not only apply to scripts. These are iframes, objects, and other elements, etc. And control the changes to HTTP headers. This was associated with the content security policy, but I will cover that later. And the Russian regulator and KCKI, following the clamorous incident of March 2022, established the following requirements. Before a JavaScript is used, it must be checked for data theft. We must verify whether it is sending data elsewhere. And with this obfuscation levels, it's not clear how are we going to perform such a check. Another requirement: if we got the hash value, if the hash changed, we have to repeat the check. We had a conversation with the colleagues. It took us a long time.
актуален вполне конкретный пласт угроз, который не
Since for front-end application, we have a specific set of threats which is not relevant for other applications.
специализированные анализаторы.
Such tasks are solved using special analyzers. We call them FAST, Front-End Application Security Testing, FAST, FAST.
Который должен решать
Let's talk about
и на каких принципах
fast analyzer tasks and the principles these must be based on.
принципы.
The
Первое.
technical principles. First,
Понять, что делает фронтенд приложение, можно только на
since
браузера.
it's only in the content layer of the browser that you can understand what the app is actually doing. So the scanner must operate a scanning principle. And the scanning must be performed during an emulated interaction with our user. It is fully ready, fully deployed browser-based application.
Только в рантайме браузера.
The analysis must be only performed in the browser runtime, so I decided not to add a dedicated slide, but under the PCI DSS, the specifications of requirements say that due to the specifics of the development of present-day front-end applications, it's only at the client browser level that you can understand what is actually going on, what they are doing. Third, scanning must be performed in the course of real end-to-end scenarios. Fear not, if you don't have end-to-end tests for front-end, the simplest end-to-end test is you visit a page, you click a few links. If it's more complex, you add some data in the form and you hit the submit button. Using a fast analyzer, it's so easy to implement using the specific set of commands. Today, we talked extensively about time to market. A fast analysis is not supposed to increase the time to market. That is, it's not supposed to take more time than running of an end-to-end case. Policies. For fast analysis, policies must be used on a whitelist basis only. What does it give us? Whitelist, maximum security, maximum reliability, and the absence of false positives. What are the 4 tasks, from my perspective, to be resolved by the fast analyzer? First, stock taking in the browser runtime of all scripts and active elements. Second, monitoring of all network queries and the application of policies to them. Third, identification of critical confidential data. And fourth, identification of the so-called dangerous browser functions. Let's drill down on each of the 4. Scripts and active element stock taking. At first sight, well, it doesn't seem that difficult. You take a look at the web page code. There are normally 2 tags. For scripts, it might be file-based or inline. Script file, script inline, but it's actually much more complex. For static entry points, there are over 100 of them in a browser. There are some objects like frames and objects which are often used as the means of attack in the context of front-end security. What makes this stock-taking process even more difficult? Scripts may use external scripts on the same page. After they're executed, they might be cleaned up. They may be deleted. So you cannot possibly take a static snapshot and see which scripts are running. So it is only dynamically that you can analyze these using the ready-made applications. Once you have analyzed the whole JavaScript and all actions have been completed. Stage 2. After stock taking, you're happy and see where your objects are. But any attacker pursues a certain goal, be that monetization or other purposes of their attack. If it's about data theft, they need to send data somewhere to the attacker's server. If it's a data script miner, you need to get the tasks, the jobs they're supposed to perform using the computational power of the user's hardware. So they need to run a certain network query. What is the difficulty? Modern browsers provide web applications over 25 channels for data transmission. These are the basic features like X, HR, and Fetch. There are other protocols, event source, WebSockets, and Beacon, form, a ping, a click, navigation, etc. That HTML elements with attributes, source or href, it might be a link. It enables you to run a get query, which may be used to transfer parameters. And in real-life attacks, web schemers no longer use fetch and XHR. They normally use an image, and with base 64 encrypted, they transmit encrypted information. Fast analyzers identify all data transmissions attempts. They identify the first list rule. They identify the country, and they specify queries and incidents identified or detected. By the way, we performed a monitoring of what data is being collected and where it goes by popular web analytics systems. And to put it mildly, we were actually surprised by the sheer amount of data being transferred and the destination countries. So probably it's high time that you should update the personal data processing disclaimer on the browser. The use of dangerous browser functions. So these are the eval function already mentioned, dynamic scripts, a couple of other functions which enable you to do the same. Then the web API provided by modern browsers. This is the camera API, microphone API, screen capture API, geolocation API. And pretty risky technologies in terms of security. They can be used to hide data theft, such as Service Worker API. Using WebRTC, if you know what it is, you can even attack local area networks, scan ports, and other nasty things. Well, actually, web APIs are a huge attack surface of the present day. Some APIs of browsers are used in 5% of applications. The question is, why would you allow to use them in other applications? Nothing has been done in this regard yet. As far as I know, similarly to the content security policy, I'm not going to dwell on, the permission policy will be introduced, and in the future it may help limit the available APIs which can be used by applications. So, how are we supposed to apply the dangerous functions policy in browsers? By default, everything must be prohibited. The use of any dangerous functions must be submitted to the operation security specialist, OPSEC specialist, application security specialist. It must be highlighted. If a dedicated application is using the webcam, they will get the permission locally, so it will no longer be identified as an incident at the next scanning phase. Detection of critical data. The principle here is reverse. Where critical data is not supposed to be detected there. From my practice, I know one case. It is a personal area. There were supposed to be multiple identity confirmation steps. This first one is full name and date of birth. Following a personal offline visit, all information would become available, including identification document data from a database. But looks like the developers were a bit lazy. They did not want to develop a dedicated API. With the date of birth entered, they would fetch all data. It was not available in the interface, but it was still stored in the browser. Fast analysis could identify cases like that. There is a dedicated control statement for OWASP, excessive data exposure.
I did see in my experience, developer has given all config server to the front, all the tokens for back-end interrelation has left. This fast analysis will control it as well. Content security policy mentioned before, If you know what it is, what you've been listening, why for all these objectives and for the script control, for data sending channel, don't you use content security policy? It's a good idea. However, it does have certain problems. I'm not going to say that not everybody uses it. However, the biggest problem is the transfer data channels. Content security policy does not control at least 2 channels of data transfer, and most likely will never control them. This is click by URL and navigation activity. To the URL, you can transfer any GET request and data will be stolen. The problem number 2, usually in content security policy, we keep some holes for our trusted services, for example, web analytics services system. So the criminal can try to steal data by using infrastructure of web analytical services. One of the most popular Russian services allows to transfer short lines while achieving certain goals. Using these, criminal can steal data in his account. Also, it doesn't control the volume of data transferred. So yes, they have permitted you can transfer, but what actually is being transferred, nobody knows. Another problem, in case of compromising application server, criminal can compromise CSP. CSP is a regular HTTP header, and he can replace it the way he wants. In PCI DSS, for these purposes, they have implemented this requirement to control irreversibility of the header. And another important topic is responsibility distribution. Who should configure CSP? Whether developer, but in this case, developer defined new scripts, took hashes, and he said that it's trustworthy. Or the security guy. But due to the fact that very often CSP is being appointed for front engines or balancers. So some of the admins can be responsible for that. Okay, let's summarize. What is to be done by Fast Analyzer? Fast Analyzer is implemented where application is ready. For example, candidate release in as pre-release testing. End-to-end scenario. We do inventory of all the active elements, the map of requests, and all dangerous functions are being tested. We permit the upload only if the policy is complied to. The approve of all the changes should be conducted by OPSEC specialists. This is real. It doesn't increase time to market because the analysis during end-to-end tests, which are automated, is very fast. White list policies, no false positives. That's why this is an optimal point for inbuilding. And DevSecOps is not end at the release. There are further stages as well, and specifically monitoring. During the monitoring stage, it is expedient to conduct periodical similar testing of the production, so that during release we would be able to achieve so that our front-end application would be secure by default and secure by design. And during the monitor, we should control that this stays like that. Also, there are additional means, front-end observability in real time. Today, I'm not going to speak about that. However, this is a next level of maturity. How do I see the maturity for safe development for the front-end applications? The first level. We start with the use of basic mechanisms which are provided to us by the browser. Mechanism you know about, like SRI, which allows us to take hashes from file scripts, define this hash in HTML code, and in case if hash is not aligned, browser is not going to fulfill and execute these scripts. Basic mechanism. Second one, content security policy, which is going to allow us to do the basic control of the network requests of the browser, and manual inventory of all the scripts should be done periodically. The next level of maturity, implement Fast Analyzer. Fast Analyzer does automatic, with necessary level of precision, full inventory of all the scripts, net requests, and dangerous functions utilization. OPSEC engineer approves all the changes. Only in the case if the control has been passed, then application has been released. Then we go to
Используем средства
monitoring, use
приложений в реальном времени.
front-end application monitoring in real-time mode. Everything is the same. We do it in runtime. In addition to that, we can control the data volume that is being received by our partners to discover if somebody violates it.
Кому интересно, я веду Telegram.
If it is interesting to you, I have a Telegram channel on safe development and safety for front-end applications. I do the overview of incidents. I publish results of pilots. I have overviews of fast analyzers, and I'm sharing best practice of how can they be implemented into our pipelines and SDLC processes. If it's going to be interesting, please subscribe.
У меня на этом все, коллеги. Можете...
Well, that's all I wanted to tell you, colleagues. You can vote for this presentation if you like it, and I'm ready to answer your questions.
Спасибо большое, Михаил.
Thank you very much, Michael. Right now, we're going to read questions that arrived through the board. Question number 1. How safe to store and transfer and variables in runtime, and how can we test the leakage if it happens? Well, safe.
Надо просто не передавать, ну, если это не какие-то...
They shouldn't be transferred if you want to keep them safe, if these are not public things.
Ну, либо какой-то...
Testing,
ну, оно будет...
whether we can use some manual testing, but it's not going to be effective, as we've been speaking about before, or you can use fast analysis. Do we need to analyze the whole repository of the project code for SAST? Isn't it sufficient file package JSON?
Для SCE анализа, да.
For SCE analysis, file package JSON is sufficient. For SAST, you need to scan your whole code. For SCA, in the framework of composite analysis, it is sufficient to use package JSON. But once again, SC analysis does not discover dependencies in the scripts of partners. Therefore, without runtime, it's not going to be full. Will you be saved from uncontrolled changes of scripts at the external resources by usage of sub-resource integrity? Good question. Yes, we've been speaking about it.
Смотрите, какая история.
Well, the situation is following here.
Вопрос в точке ответственности.
It's the point of responsibility question. Who is responsible for sub-resource integrity? For example, we constantly are talking about library vulnerabilities. Versions of dependencies have to be lifted by developers. Developers often lift them, and application code is constantly changing because the code of these dependencies is also changing. When developers have collected new versions, assembled them, and how the deploy is happening in sub-resource integrity context, we take automatic hashes from all the scripts, download them to CDN, and the question, what are we defending from? If we're defending from compromising CDN and somebody will replace the script, then it will protect us from that. But if the attack against supply chain and our developer downloaded vulnerable library or inbuilt, the integrity resource is not going to save us. Functionality of fast analyzer, what is missing in the interactive mode and other DAST solutions? What is missing there? Well, the key difference here, what I was speaking about WASP, it's DAST. We're speaking about fast. The key thing that has to be available in fast, you should have a real browser which executes the JavaScript code completely, our own and code of our partners. In other words, fast and DAST have totally different objectives and different technological stack used for their foundation. Big site, big CSP.
Получается, что так.
Looks like that, yep. What is to be done with phishing as the biggest web problem? How fast can help you with that?
Может помочь.
Fast can help.
Во-первых, за счет
First of all,
целостности и выявления изменений.
At the account of integrity control and discovery of changes. For example, if criminal will inject his own script, which contains that functionality, which will show this phishing banner, we will be able to see these changes. The second thing, Perhaps
По сетевым запросам, то есть если
up to the network request in a framework of end-to-end scenario, some of the phishing banner, if it's going to be shown, and maybe some data will be sent somewhere, we will discover it. If you mean phishing through the transition following link to the criminal's resource, yes, we will be able to see that, because click by link, it's a navigational event, and Fast Analyzer will be able to see that as one of the data transfer channels. What is to be done with old browsers, which cannot work with new security headers?
Ну, вопрос интересный.
Well, it's an interesting topic. I would like to say that 99% of modern web is not related to it. Everybody's using modern browsers, maybe for some legacy applications from specific spheres or intranet purposes. That's where old browsers are used, but everybody has to switch to new browsers. Dump qualify, is it evil or good? Dump qualify. Don't qualify. Don't qualify is good.
Как строить модель угроз веба?
How can we build gross web models? Are there ready models that you can recommend? I have my own threat model for front-end applications, only for front-ends, not the whole web. And a little bit later in the channel, I'll share it with you. What solutions for fast analysis do exist today, and which of them can be applied? The way as I described it, speaking about these four main directions, these solutions, they do not exist. This is a promising story. Separate cases are available abroad and in Russia as well. I'm not going to give you the names, but you can approach me and I can share with you, or you can wait for the overview in my channel. Signatures for blocking through geo-IP. Web domain base, is it used? Where signatures are coming from? If we have transitive dependencies which are going to change hosting address and everything will be dropped, how can we see this?
Fast
analysis is not using any signatures. It's principle of operation not through the blacklist but whitelist. So everything which is not under permitted, considered as an incident. In other words, it excludes false positives, and you don't have to update signatures, and you get maximal reliability and security. How can we control dynamic scripts from partners? Analytics, public polls, chatbots, and can Fast normally work with iframe integrations? Yes, Fast works on a content word, so it sees all the frames, anything inside of them, complicated frames, etc. Because by the level of abstraction, we are a little bit below, so we see all requests and elements in all the inbuilt frames as well. And the beginning of the question, what? How can we control dynamic scripts from partners? Yeah, Fast will see what these dynamic scripts do in the end-to-end scenario. But you have to understand that this is a scanning mechanism. So if in the end-to-end scenario something will happen, you will see what was done by it. But if you would like to control in real time after deploy, this is a front and observability plus solution. Can you give us actual tool for Fast open source or commercial ones? We would like to hear an example of such a tool. Specifically, I'm not going to call, but in the channel, I will do the overview a little bit later.
Назовите предъявление каких-то требований.
Can you give us requirements to front-end developments secure by design? Can it complicate development at the front? Requirements, well, the classical one, classical approach to security, so-called hardening and reduction of attack surface. With web API, there shouldn't use any web APIs if they are not needed. The question, how can we control that? Well, and this was the presentation.
Минимум зависимостей.
Topic. The minimum of dependencies. When I see landing, where they collect phone and the name, but JavaScript of dependencies weighs 20 gigabyte. Well, it's very strange. You have to review the tool. The tool should not just be effective for framework and task solution, but it also has to be safe and shouldn't increase the surface of the attack. After scripts received by the criminal, will he be able to use the same fast approach but in a reverse direction if the code is not obfuscated?
Нет, смотрите, fast работает.
No. Well, fast works on totally different level of abstraction.
Сам скрипт.
So the script itself does not have any understanding. Well, the script is executed by browser. So the criminal who implemented the script, he will not be able to understand that below there is a certain level of control.
Как вы проверяете single
Case question. How do you check single-page application for the security problem?
single page
Once again,
application
single-page application for the security problems. Same as single page is not different from any other application.
Опять же, так как fast это
Once again, because fast is a core of the browser, it's completely defines and executes JavaScript,
что-то вроде
something that is called something like server-side rendering.
end-to-end сценария.
Therefore, in a framework of end-to-end scenario, you can wait for download of the page, introduce into some forms any data, press buttons, and realize specific end-to-end case on your single page. So, in principle, there is no difference here.
Как мы контролируем
And a final question, how do we control the country in a whitelist if there is no geo API?
Я, кажется, понял, про что был вопрос про сигнатуру.
Okay, I understand what was this question about signatures.
Ну,
Yes, the country,
это просто база данных.
it's not a signature, it's just database of compliance of
Ее нужно регулярно обновлять.
IP addresses to the countries. It has to be updated regularly. Yes, this database has to be in the solution, but there is no another method to define the country by IP.
Последний вопрос. Сейчас еще появился.
Well, it's not the last question. There's another one.
Сценарии для проверки
Who generates scenarios to check functionality through fast of specific software?
Зависит, ну, от вашего.
Well, everything depends here from your business processes inside of the company.
То есть вообще желательно покрыть максимум end-to-end.
Generally, it's desirable to cover maximum end-to-end tests, but it's the level of maturity. For example, if you have an online bank or the account, basic end-to-end scenario, entering the page, login password, it can be one-time password,
Прошлись по
they
основным
drop
правилам.
you into the
Там новую заявку.
room. Well, you can leave a new application out there in the account. So developers and security people have to unite their efforts, and they have to look at those end-to-end scenarios
В которых есть конфиденциальные данные.
where there's confidential data or some critical functions,
Тут уже по
and jointly they have to agree according to your internal threat model. Now, no more questions. Okay, thank you very much, Elena. Thank you.
Подождите.